we can look at our data to figure out the actual yield of carbon dioxide. The mass before the reaction was 5.98 grams. And the mass after the reaction was 5.85 grams. We can subtract to find the amount of carbon dioxide that bubbled away. This amount is 0.13 grams. This is the actual yield. Now, to figure out the theoretical yield, we will need to perform a stoichiometry problem using the balanced equation. We must also remember the fact that we started with 0.23 grams of sodium bicarbonate. The question is, how many grams of carbon dioxide will be produced if 0.23 grams of sodium bicarbonate react? Of course, the first thing to do in any stoichiometry problem is to balance the equation. But this equation is already balanced. So the first thing we need to do with this problem is to put our problem into the question mark format. How many grams of carbon dioxide equals 0.23 grams of sodium bicarbonate? I need to switch grams of sodium bicarbonate to moles by using the molar mass. So I put 84.0 grams of sodium bicarbonate on the bottom and 1 mole of sodium bicarbonate on the top. The grams of sodium bicarbonate cancel. Now that I have moles of sodium bicarbonate, I'm ready to use the mole ratio to make the switch to moles of carbon dioxide. The equation is balanced with all coefficients of 1, so I put 1 mole of sodium bicarbonate on the bottom and 1 mole of carbon dioxide on the top. The moles of sodium bicarbonate cancel, leaving me with moles of carbon dioxide. Now I can use the molar mass to convert moles of carbon dioxide into grams of carbon dioxide. I put 1 mole of carbon dioxide on the bottom and 44.0 grams of carbon dioxide on the top. The moles of carbon dioxide cancel. And finally, I multiply 0.23 times 44.0 and divide by 84.0 to give me 0.12 grams of carbon dioxide. Very good. Remember, my student has helped you to calculate the theoretical yield. Now that you have both the actual yield and the theoretical yield, we can calculate the percent yield. We simply divide the actual yield, 0.13 grams, by the theoretical yield, 0.12 grams, and multiply by 100%. That gives us a yield of 108%. Does that make any sense? Can we really have a percent yield over 100%? Well, the obvious answer is no. However, remember that there is a certain amount of experimental error in any experiment. Since we found the mass of a product that disappeared, it seems reasonable that we may have figured this number a little high. The good news is that we are very close to 100%, certainly within the accepted range of experimental error. Mr. Mole thinks you should try one more problem before we call it quits for the day. So, here goes.
What is the percent yield of carbon dioxide when 5.99 grams of propane is burned and 12.052 grams of carbon dioxide are collected? This problem is a good review of some old material, as well as a good lesson in today's material. Your first step should always be writing a balanced equation. Next, you need to remember how to write the formula for propane.
Let's look at this example. How would you write the formula for the hydrocarbon propane? First of all, because the name ends in ane, we know that propane is an alkane with the formula CnH2n plus 2. The prefix pro is used when n is equal to 3. That means that using the formula CnH2n plus 2 gives us a subscript of 3 for carbon. The subscript for hydrogen is found by multiplying 2 times 3, which gives us 6, and adding 2. We find that the subscript for hydrogen is 8. Propane's formula is C3H8. Great review! The question says that propane is burned. Do you remember what that means?
Combustion reactions usually give off a large amount of heat and light. Combustion, which is normally called burning, involves a substance combining with oxygen from the atmosphere. An important combustion reaction is that of hydrocarbon. Recall that hydrocarbons are compounds that contain only hydrogen and carbon. In a complete combustion reaction, hydrocarbons combine with oxygen to produce carbon dioxide and water. So the burning of propane is a combustion reaction in which propane combines with oxygen to produce carbon dioxide and water. Write a balanced equation for this reaction in your notes. The problem asks you to calculate the percent yield, and that means you need 2 pieces of information, the actual yield and the theoretical yield. Read the problem again and write the actual yield in your notes. Now you must work a stoichiometry problem to find the theoretical yield. Start by putting the problem into the question mark format. Your first step is to use the molar mass to change the grams of propane into moles of propane. Be sure to show the canceling of the grams. Now you can use the mole ratio to make the switch to moles of carbon dioxide. Again, don't forget to cancel your units. You can use the molar mass of carbon dioxide to convert moles of carbon dioxide into grams of carbon dioxide. All you have left to do is multiply and divide to get your final answer. You're not finished yet. Look back at the problem. You are asked to calculate the percent yield. The actual yield was given in the problem, and you just solved for the theoretical yield. You are now ready to calculate the percent yield. You should have gotten 67.1%.
We hope you all got that one correct. As always, your local teacher has more for you to practice before we meet again. Now, it's time to check yourself with the chemistry quiz.
Cumulative review question number 1. Stoichiometry is the study of what kind of relationships in a chemical reaction. A. Quality. B. Quantity. C. Reactants. D. Products.
Cumulative review number 2. What do the coefficients in a balanced chemical equation always represent? A. Gram ratio. B. Mole ratio. C. Both A and B are correct.
And now for some questions from today's lesson. Number 1. All stoichiometry problems involve starting with information about one substance and finding information about a different substance. What is always involved in making the switch? A. The mole ratio. B. The balanced equation. C. The subscripts from the formulas. D. Both A and B are correct.
Number 2. You are given the mass of one of the reactants in a chemical reaction and asked to find the mass of one of the products. What is your first step? A. Get out a balance. B. Check to make sure the equation is balanced. C. Make the switch using the mole ratio. D. Give up. It's too hard.
Number 3. You are working in the lab and find the mass of one of the products in a chemical reaction. What is it called? A. Actual yield. B. Theoretical yield. C. Percent yield.
To solve number 4, you will need this balanced equation. You will also need a periodic table. How many grams of water will be produced if 2.6 grams of oxygen gas react? A. 1.5 grams H2O. B. 5.2 grams H2O. C. 23 grams H2O. D. 2.9 grams H2O.
You will need your answer from number 4 to solve number 5. 2.6 grams of oxygen gas reacts with hydrogen gas to produce 2.4 grams of water. What is the percent yield? A. 63%. B. 83%. C. 160%. D. 46%.
We're not quite done with this math stuff yet. Next time, we'll try some problems with a twist. Hey, that's pretty tasty, Mr. Mole. But in our next program, we'll also enjoy some banana splits. Mr. Mole can't wait. See you then.